4 times more accurate. That is what a properly built RAG system delivers compared to a base LLM answering questions about your own data. Yet 73% of teams building RAG applications ship a version so broken it hallucinates on their own documents. Here is the exact architecture difference between the naive version everyone builds first and the production version that actually ships. We are covering chunking strategies, embedding models, retrieval algorithms, and re-ranking, the 4 layers that separate a demo from a product. RAG stands for Retrieval Augmented Generation. The idea is simple. Instead of baking all your knowledge into model weights during training, you store it in a vector database and retrieve the relevant pieces at inference time. OpenAI showed in 2023 that RAG reduces hallucinations by 38% on domain-specific queries compared to base GPT-4. By 2025, over 60% of enterprise LLM deployments use RAG as the core architecture. Your documents, your database, your control. No fine-tuning required. The naive version looks like this. Split your PDF by 1000 characters. Embed everything with text embedding ADA002. Search by cosine similarity. Feed the top 5 chunks to GPT-4. Ship it. And it fails. Why? Chunk boundaries cut sentences in half. The embedding model loses context. The retriever returns irrelevant chunks because the user's question uses different vocabulary than the document. In one Stanford benchmark, naive RAG scored 41% accuracy on domain-specific QA. Production RAG on the same dataset, 87%. That 46-point gap is the problem we are solving today. Production RAG has 4 layers. Layer 1 is smart chunking. Not character splits, semantic splits. Use a sentence transformer to detect topic boundaries. Chunks should be 256 to 512 tokens with 50 token overlap. Layer 2 is the embedding model. Use a domain-specific model, not a generic one. BGEM3 outperforms text embedding 3 large by 12% on technical documentation. Layer 3 is hybrid retrieval, combine dense vector search with BM25 sparse search. This alone lifts recall by 18%. Layer 4 is re-ranking. Run a cross-encoder on your top 20 results and keep only the top 5. Let me give you real benchmarks. On the BIR retrieval benchmark, pure vector search hits 43.8 NDCG. Hybrid search hits 51.2. Add re-ranking and you reach 58.7. That is a 34% lift with 2 extra lines of code. Latency? Naive RAG adds 800 milliseconds per query. Optimized production RAG with caching sits at 180 milliseconds. Cost? Embedding 1 million tokens with text embedding 3 small costs 2 cents. Re-ranking those results with a Cohere re-ranker costs 1 cent per 1,000 queries. Accuracy up 34%, latency down 77%. Here is the exact stack in 2026. For the vector database use grant, it is free, open source, and handles hybrid search natively. For embeddings, use the BGEM3 model via Hugging Face, 0 API cost per token. For orchestration, use Llama Index with the hybrid retriever class, 3 lines of code to combine dense and sparse search. For re-ranking, use Cohere re-rank 3 in.1 API call, 23 milliseconds added latency. For evaluation, use Ragas, it scores your RAG system on faithfulness, answer relevance, and context precision automatically. This entire stack runs for under $50 a month at scale. In 12 months, RAG is getting more powerful, not less. Multimodal RAG will pull from images, diagrams, and PDFs in one query. Agentic RAG will let the system decompose a complex question into 5 subqueries and merge the results. Graph RAG, pioneered by Microsoft, represents your knowledge base as a graph, boosting multi-hop reasoning accuracy by 62% over flat vector search. The teams building production RAG infrastructure today are building the data moat that will be impossible to replicate in 2027. 5 steps to ship production RAG this week. Step 1. Audit your chunking strategy. If you are splitting by character count, switch to Llama Index Semantic Splitter Node Parser today. Step 2. Benchmark your embedding model. Run MTEB evaluation on your actual documents. 30 minutes of compute reveals which model wins on your data. Step 3. Add BM25 hybrid retrieval alongside your vector search. Llama Index Hybrid Retriever is 4 lines of code. Step 4. Add a re-ranker before your LLM call. Cohere Re-rank 3 or BGE Re-ranker V2M3 both work. Step 5. Set up RAG's evaluation. Run it on 50 questions from your domain. You now have a real quality signal, not just vibes. RAG is not hard to implement. It is hard to implement correctly. The 4-layer architecture, smart chunking, domain embeddings, hybrid retrieval, re-ranking is the difference between a hallucinating chatbot and a production system your users trust. If you found this useful, subscribe for weekly deep dives on AI engineering patterns. And drop a comment answering this: what is the most painful RAG failure you have seen in production? I read every one.